So today's topic is about transformer. In transformer we have two windings, primary winding and secondary winding, and both the windings are isolated. It is only coupled through magnetic field. So the current flowing in the primary winding is IP. The current leaving out of the secondary winding is IS. The number of turns in the primary is NP and the number of turns in the secondary is NC. So basically the transformer works on the principle of mutual induction. We all know that the voltage induced in a coil is given by minus N d pi by dt, that is number of turns into rate of change of flux linkages. So similarly, when your primary is given a AC voltage, this will produce a magnetic field. Okay, that magnetic field gets coupled to the secondary. So the magnetic field strikes the secondary coil, which is a conductor. Therefore, an EMF is induced in that coil. So the secondary voltage is given by minus ns d pi by dt. So from this equation, we have the equation 1 and equation 2. Now 2 divided by 1, that is Vs by Vp, secondary voltage divided by primary voltage, is equal to d pi gets cancelled, minus gets cancelled, ns by np, that is number of turns in the secondary divided by number of turns in the primary. Okay, generally in transformer, input power is equal to output power. Input power means this side, primary side, output power is the load side. So input power, power is V into I, so Vp into Ip is equal to Vs into Is. So from this relation we have Vs by Vp is equal to Ns by Ip. From this equation, Ip by Is is equal to Vs by Vp. That means, forget about this, if you cross multiply, Vs into Is is equal to Vp into Ip, which is equal to K. This K is called the transformation ratio. Now suppose if secondary turns, this is secondary, the number of turns in the secondary is greater than number of turns in the primary. That means primary you have very less turn and secondary you have more turns. So that is step up transformer. Step up transformer means you can step up the voltage. Okay. Suppose if the primary turns is greater than the secondary turn, that means if you see this diagram, the primary turns is higher, secondary turns is lesser. So this is a case for step down transformer. And there is one more transformer, that is NP equal to NS, number of turns in the primary is equal to number of turns in the secondary. That is, it is called 1:1 transformer. What is the purpose of transformer in this case, last case? This is for isolation. Isolation means this is primary side, this is secondary side, this is electrically it is not connected. Both these circuits electrically is not connected. Only it is coupled through the magnetic field. So there is a isolation between the primary circuit and the electrical circuit. If anything electrical fire or happens in the primary side, it will affect only the primary and secondary is not affected. Suppose if there is an electrical short or something happening in the secondary side, there is nothing is going to happen in the primary side because both are isolated. So the very purpose of using NP equal to NS is for isolation. Generally transistor, one of the main application is isolation only because primary and secondary side is isolated. But in this case, whatever you are giving the input voltage, same output. Suppose 10 volts means you will get only 10 volts because the turns ratio is same. Okay, isolation between the two circuits. Now coming back to okay, now we will see about the efficiency. Efficiency, general formula is output power by input power. So we have some losses because this is if two windings are very close, it gets coupled, but 100% it is not coupled. The total power or energy is wasted through some form. We will see those losses, okay, in the next topic. So the efficiency we can make very close to 92%, 95% like that. So definitely with the proper designing of transformer, we can get roughly around 86 to 90%. Okay. So efficiency is output power by input power. Now I will speak about the construction of the transformer. So if you see, this is primary side in this transformer and this is secondary side. Okay. Now you have a E core which is serrated. Serrated means it is not a solid thing, it is serrated. Okay, you have primary windings and secondary windings, and this is the base. And primary and secondary, the copper we are using is a enameled copper wire. Enameled copper means there will be a coating which is insulated. That means even after winding, two conductors is isolated, so there won't be any shorts. So we must use a good quality enameled copper wire. Otherwise, what will happen? The transformer primary or secondary gets short circuited. We have to avoid that. So this is for improving the efficiency and avoid the loss. Loss means we have so many losses. Iron loss, copper loss, and so many things are there that we will discuss in the topic. This is a low power transformer which is used in our circuit boards basically. If you look into the EV line connections and all, you will have high power transformer. Okay, very big transformer. When you go by a roadside, you can see those transformers. So generally, the flux will be surrounded everywhere. So going near the transformer should be avoided. Whenever you walk along the roadside, whenever you see a transformer, see that you are just away. And one more thing about the transformer is the input frequency and the output frequency remain same. Suppose if you give 230 volts 50 hertz AC supply, the 50 hertz secondary also 50 hertz, that means it cannot alter the frequency. 50 hertz means 50 hertz. Suppose if it is going to be 110 volts 60 hertz, then you can step up or step down this 110 volts, but the 60 hertz remains same. Input and output frequency remains same for the transformer. See about energy losses in a transformer. Okay. Now we have three types of losses. One is copper loss, core loss or iron loss, or otherwise called as hysteresis loss, and flux leakage loss. Okay, copper loss. What is copper loss? So if you want to make a winding, copper winding, the copper itself has some resistance. That means only in an ideal coil there won't be any resistance. Okay, but in practical case, all the coils definitely will have resistance because a wire has a resistance. So if this is a coil, the equivalent circuit will be a resistance followed by a coil. So power is dissipated in this resistor. That is, energy is dissipated in the resistor because of that electrical resistance. That is copper loss. So this we cannot avoid. Next one is core loss or iron loss or hysteresis loss. Hysteresis loss is generally the hysteresis curve will be like this, H and B. So it rises, falls, goes back like this, comes again and joins here. So H is amperes per meter, intensity of magnetization amperes per meter, magnetic flux density is Webers per meter square. Okay. Now core loss means iron loss or hysteresis loss. So and in the core, eddy current flows inside the core. So we call it as eddy current loss. What is that eddy current loss? The flux, we know that primary and secondary gets linked by mutual induction, and we are supplying with the alternating field. Therefore, the flux also gets alternating. That is, phi is equal to phi sin omega t. So because of that, eddy current flows within the core itself, and that is a loss. And this hysteresis loss is, if you plot the graph between H and B, that is amperes per meter, that is current flowing through the coil, and the magnetic flux density, you will get a curve like this. Here one important point is, when I is equal to 0, the magnetic flux density is not 0. This property is utilized for recording in magnetic tapes, because even the current is 0, the magnetic material is able to withstand, hold the information, because when I is 0, and in the same magnetic property, when you supply a negative current at this point, it gets erased. So this hysteresis concept is being used in magnetic tape for recording. So this is a hysteresis loss. So the hysteresis loss happens in the core, and it is transformed as heat. Okay. and we told about eddy current loss also. Now the flux leakage loss. Flux leakage loss means if you have primary one side and secondary other side, so the flux gets coupled here also and it goes in all directions. So what will happen? Magnetic field. So what will happen? The flux linked with the secondary is low. So there is some wastage of energy all around. So that is called flux leakage loss. But how it has to be minimized? Minimized by winding coils one over the other. That means you suppose inside you have winding primary and outside if you have secondary winding, what will happen? Inside you are giving power. So what will happen? The flux will come all around and that is captured by the secondary coil. Therefore we can minimize the flux leakage. Suppose if you have primary this side and secondary this side, then the coupling will be here. The energy spreading out all around is wasted. So best way of winding the transformer is putting the primary inside and the secondary outside. Then most of the flux linking with the primary winding to secondary winding, the efficiency is improved. So these are the very important losses that happens in the transformer. Okay, that's all about energy losses in the transformer. Thank you.